5.2, independent and dependent events. Starting with an independent event, and independent events are when the occurrence of one event does not affect the occurrence of the other. So let's think about this for a minute. We're going to discuss an example here, and we're going to talk about flipping two coins. Do you think when I flip the first coin, and I can get a head or a tail, that based on whether or not I get a head or a tail, that will affect what I flip on the second coin? And my initial thought would be probably not. I don't think flipping a head or a coin on the first one is going to make the likelihood of flipping a head or a tail on the second one any different. So those would be called independent events. Now, the probability of independent events could be looked at using this formula. So the probability of A and B happening together should equal the probability of A and then the probability of B. So let's say I want to find the probability of flipping two heads. So there's two ways we can look at this. The first way we can look at this is by using a sample space. So on the first coin, I could either flip a head or a tail. On the second coin, I could either flip a head or a tail or a head or a tail. If I look at this sample space, I'm going to get that I could flip a head and a head. I could flip a head and a tail. I could flip a tail and a head. I could flip a tail and a tail. From this sample space, I want to know the probability of flipping two heads. Well, that would be right there, which would be 1 out of 4. Now, that right there was that probability. So the probability of a head and a head. That should be equal to this probability over here, which we're going to look at them separately. So now let's look at the first coin. What's the probability on the first coin that you flip a head? Well, if you're looking at one coin, you have two options. You could get a head or a tail. So the probability of a head would be 1/2 times the probability that I get another head. So now I'm on my second coin. On my second coin, I have the same options. I could get a head or I could get a tail. So probability once again is 1/2. If we take 1/2 times 1/2, we get 1/4. Do you notice that these probabilities, whether I use a sample space or if I use the rule of multiplying the two probabilities together, are the same? And the reason they're the same is because flipping two coins are independent events. Example 1. We're going to determine whether events are independent. So, example 1, a student taking a quiz randomly guesses the answers to 4 true-false questions. Use a sample space to determine the following. Letter A. Determine whether guessing question 1 correctly and question 2 correctly are independent events. Now, we actually did this example back in section 5.1, so we've already listed the sample space. So, for example, if you forgot, the student could guess I, which means incorrect, 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 and then they go from there. Now, it wants to know whether guessing question 1 correct and question 2 correct are independent. So probability of 1 correct and 2 correct should equal the probability of 1 correct times the probability of 2 correct. So I'm going to go back and I'm going to look at them together using my sample space. If I get this one, we have 1 and 2 are correct. 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 and I think that's it. So there are 16 total outcomes if we count them up. 4 out of 16, which is going to give me 1/4. Now I'm going to go look at them independently. So probability that I guess number 1 correct. Well, that would be this one. This one. That's 2, 3, 4, 5, 6, 7, 8. So that's 8 out of 16, which is 1/2. Times the probability that I guess number 2 correct. Okay, and actually we could make this a little more simpler versus looking at our sample space, because when you're guessing the answer to number 2, it's a true or false. So you can either guess right or wrong, so it's kind of like flipping the coin. So we know you're still going to have half the chance of getting it right or wrong. If we multiply 1/2 and 1/2, we get 1/4. This 1/4 equals this 1/4. So yes, these are independent. Meaning that if you guess question 1 correctly or incorrectly, it's not going to affect whether or not you guess question 2 correct or incorrect. Part B, figure out whether or not guessing question 1 incorrectly and guessing 2 correctly are independent events. So now we're trying to do the probability of 1 incorrect and 2 correct should equal the probability of 1 incorrect times the probability of 2 correct. Starting out over here, we're going to use our sample space, and I want the first one incorrect, the second one correct. So once again, that's 4 out of 16, which is 1/4. Now I'm going to come over and I'm going to look at these separately. So the probability of guessing the first one wrong, well, you have a 1/2 chance of doing that because you can either get it right or you can get it wrong. Probability of guessing the second one correct, well, again, you have a 1/2 chance because you can either get it right or get it wrong. When you multiply, that's 1/4. This 1/4 is equal to that 1/4. So again, yes, these are independent events.